Hi guys, are you able to see me? Hi everyone. So you're able to see me, right? Can anyone confirm in the chat? You guys are able to see me? Yeah, I'm good, Sadiq. So whomever we have the subscribers, right? So they only can join the. They only can able to comment. Okay. So this is what our topology, guys. Okay. Well, everything is going on. Let me check here as well. Okay. We have been waiting for you. Yeah. Thank you. So we have 13 members, right? So we will wait for 2 more minutes, then we'll start actually our concept, like the NAT concept. Let me try to put the message in the group chat as well. 13, 14. Yes, guys. So we have the 14 count, right? Let's wait for 2 more minutes, and then we'll start our session. So whomever are facing the issue, like so they're unable to chat in the group chat, so they need to be subscribed first. So once we get the subscription, then only we can see the messages from the subscriber users. So we have almost all 17. Okay, let me start, guys. Okay, we will start. So this is what our topology. So we are going to discuss today about the NAT. So what is NAT and how NAT used to be work? Okay, so and the different types of NAT in the production networks we have, right? So let me go through this lab, right? So myself, like see, I'm the trainer of Network Ninja. So today we are going to discuss about the NAT topic. NAT stands for Network Address Translation, right? NAT stands for Network Address Translation. So before we understand NAT, right? So before we understand NAT, so why we really require NAT? That we need to understand. So that is going to be help you in even in the interview perspective as well. So when we are going to attend appear in the interview, so this is a very important concept in the interview aspect. Okay. So generally, guys, first walk me through about my topology. So this is what my topology, right? So in this topology, here we have an internet, right? See, this is our internet service provider. Okay. So here we have an internet, right? So internet service provider. So we are going to take the connectivity from the we are going to take the connectivity from the internet ISP. So this is what our ISP. You can consider any ISP like Airtel, Geo, Tata, or BSNL, any provider. So this is the ISP side router. So I mentioned here even ISP router, right? So we are not going to do any configuration in this particular box, right? In this particular router. So this router is ISP's router. So ISP is having somewhere in your city. So from there, they have the connectivity to their router. From there, this is what our WAN circuit, right? Wide area network. And here below the router, this is our LAN circuit, like LAN network, local area network, right? So between here, so I used to get the IP address from the provider. So this is the provider network, guys. This is completely the provider network. We are not going to do anything in this provider network. But however, right, so here we are going to take the WAN public IP pool. Here we are going to take the WAN public IP pool, WAN public IP pool, and we are going to take mostly generally I'm going to take a slash 30 subnet, but for in this lab I'm going to take like 100.100.100.0 slash I'll take slash 24, guys. I'll take slash 24. I'll take slash 24. So here this subnet I'm going to take for the WAN purpose, and for the LAN purpose I'm going to take like 192.168.1.0 slash 24. This is my LAN subnet. So as we know, right, so whenever if you don't do the natting here, network address translation in this particular WAN facing router, so what generally will have, right? So before we learn about NAT, network address translation, we need to understand what is IP address. What is IP address or IP addressing, right? So IP address and IP addressing. In IP address, Internet Protocol address, we have a different classes of IP address, right? So IP address stands for Internet Protocol. So in Internet protocol addressing. So in IP address, we have a different classes, guys. So when you check our previous videos, also I've clearly mentioned there. So in the IP addresses, we have two different versions. IP address, we have two different versions. One is IP v4 internet protocol version 4, and the second one is we have IP v6 internet protocol version 6, right? So in IPv4, guys, in IPv4 we have a five different classes, right? I'll mention here: class A, class B, class C, class D, and class E. So class A, B, and C we are going to use for LAN and WAN purpose, LAN and WAN purpose. So here particularly we are going to assign the IP addresses here in this particular interface. This is our WAN, right? So here we are going to use the ranges from class A, B, and C. And even for the LAN purpose, we are going to use for class A, class B, class C network. So class D is reserved for multicasting. So class D is reserved for multicasting, as well as class E is reserved for R&D, research and development. R&D, research and development, right? So this is what the IP addressing. And we know that whenever the LAN users are trying to be, so this is our LAN users, right? So whenever the LAN users are trying to access the internet, so generally we will have a web services, right, over the internet. So we have a multiple different kind of services. You can consider like a Gmail service we have, right, for the mail purpose, and we have the YouTube, right? So we have the YouTube and we have the Facebook, Instagram. So these are all are hosted over the internet. So to access this particular service from the LAN users, what we required, so every LAN user, so in our LAN we are going to use for private IP addresses, right? So here we are going to use private IP addresses. So as we know that from our basic scenarios or the from the basic classes, right, the introduction classes and all, so the private IP addresses are not able to route over the internet. So whenever your private IP address, right? So whenever your private IP address, like consider this is your source IP 1.10. So if you have the source IP source IP 1.10, and the destination IP is your public IP address. So once this packet reaches to the router, if you don't perform NAT here in this particular router, so this packet used to be sent to the ISP's router. So ISP's router used to be drop this, because once it open the packet, right, it can see, this particular router can see that, right? So the request is coming from the private IP address, but we learn that private IP addresses are not routable over the internet. So that's the reason the ISP router is going to be drop your packet here in the ISP's router itself. So to overcome that issue, right, so in the IT technology we have what, we have the NAT technology. We have NAT technology. So this is what about the the brief about IP addressing, guys. So IP address stands for internet protocol. So we have the two different versions, version 4 and IPv6 version 6. Again, the IPv4 is divided into five classes: class A, class B, class C, which we are going to use for LAN and WAN purpose, and class D is reserved for multicasting, as well as class E is reserved for R&D. So that multicasting is again same thing, guys. When you are going to use the dynamic routing protocols, right? when you are going to use the dynamic routing protocol, so to form the neighborship between the routers from router 1 to router 2 or router 2 to router 1, it used to send the hello messages, right? It used to send the hello messages. So the hello messages are going with the help of multicast address. Every routing protocol will have a reserve multicast address that we will see in our we saw in our previous classes, right? So what we understand from this, the from five about this 5 minutes in this 5 minutes, right? So the thing is, whenever the private users are trying to be access internet with the help of private IP address, that is going to be drop in the ISP's side. So now we should know what is the private IP ranges. So each and every classes we have a private ranges, right? So if you see here, like in the class A, the range will start from 10.0.0.02, right? So it is going to be start end at 10.255.255.255, right? So this is what your class A range, guys. So when the users, when you are going to assign the IP address for this particular LAN user, this private IP range. So if the packet is going towards your router, like your WAN router, so without doing any translation or without changing the private IP address, if this router sends to that ISP's router, it is going to be dropped because it is seeing the private IP address that ISP routers don't know. They don't have the written route to reach this particular ISP router. Even though we studied that the private IP addresses are not able to route over the internet. So since from here, right? So this is your completely WAN phase. So here we used to use the public IP addresses, right? Here we are going to use the public IP addresses. So likewise, guys, for class B also we have the range, right? So 172.16.0.0, right? 172.16.0.0, and this range is will go till 172.31.255.255. So this is what the range of class B, the private IP ranges. So so why I mentioned this, right? Before we are starting about the NATing, right? Network address translation, we should know what is the private IP address and what is the difference between the public IP addresses. So if you know about the private IP and the public IP, then only you will understand clearly the NAT concept. So likewise, guys, we have the private IP ranges in the class C also. So it is going to be start from 192.168.0.02 till 192.168.255.255. So these three are the private IP ranges. So whenever the user is trying to be access the internet, so without translating your private IP address, if the request is going directly to the ISP's router, so it is going to be dropped. So to overcome this, so we are going to be perform the NAT, network address translation. To overcome this, we are going to perform the NAT and network address translation in the edge router. So this is our edge router. So sometime, guys, in the live production network, so this is called as a PE router, right? Which means provider edge router. And we are the customer to the provider. So here we can mention CE router, customer edge router. Between PE and the CE, between P and the C, we have the public IP addresses. So this public IP we are going to take here, right? And these are our the LAN users. So we are going to assign this private IP addresses, the respective private IP addresses on this particular LAN machine. And without performing NAT, without perform NAT, when we try to reach to internet, right? So my machines will not able to reach the internet, so our machines will not able to reach the over the internet. So to do that, what we required a NAT. So we need to perform a NAT, network address translation, on the edge router. On which edge router? CE router, customer edge router. So here in you need to perform the NAT. So this is what the basic things about the NAT. Now we will discuss about how many types of NATs we have in our production network. So how many types we can perform the NAT. So before I wipe out this, so this is what the IP addressing, guys. IP stands for Internet Protocol. We have two versions, and IPv4 is again divided into five classes. These five classes are reserved for the special services like class A, class B, class C is going to be used for LAN and WAN purpose. WAN stands for here, right? So the connectivity from your office router, like from CE router, customer edge router, to PE router, provider edge router. This is your WAN, and LAN is your downstream, right? Since from your CE router or the WAN edge router to whichever the connectivity we have, this is we used to call as a LAN. So there we are going to use for like the class A, class B, class C IP addresses, and class D is reserved for multicasting, right? To form the neighborship in the dynamic routing protocols, we required a multicast address. By using multicast address, routers used to exchange the hello messages. And class E is reserved for R&D, research and development, guys. Research and development. So and again, so we discuss, right? There are some few private IP addresses. So from each class, from class A, class B, class C, we have the ranges of the private IP address. And the class A's private IP range is this. It will start from 10.0.0.0 to 10.255.255.255, and class B's private IP range is 172.16.0.0 to 172.31.255.255. Likewise, we have the range for the class C as well. For the private range is 192.168.0.0 to 192.168.255.255. So this is what the overview about the before we perform the NAT, guys. Now we will discuss how many types of NAT we have, right? Where we need to be perform the NAT in our production networks, right? So that we are going to discuss in a moment. Let me wipe out this. And guys, we are going to do the lab as well. So each and everything, whatever we are going to discuss now, so we are going to do the lab as well. First, we will go come across all things. So what is the possible things we have in our natting? Then we'll perform the live trouble, like the live natting. If the nat is not possible, if the nat is not happening, like if you are facing any issues, then we'll perform the troubleshooting as well, guys. We are performing the troubleshooting as well, right? Now, so we are going to understand about NAT. What is NAT? So generally, NAT means network address translation. In NAT, okay, we have three different types. One is static NAT, and the second one is a dynamic NAT, and the third one is PAT. PAT also stands for port address translation. So these are all the three types we have in the NAT. NAT stands for network address translation. In network address translation, we have three different types. One is static NAT, the second one is dynamic NAT, third one is PAT. PAT stands for port address translation. So we'll discuss about a static NAT. What is a static NAT? Okay. First of all, NAT stands for, like, it is going to be translate the IP from one IP to another IP. It could be a private to private or private to public, but in the static NAT it is nothing but one to one mapping. Okay, static NAT used for inbound traffic, guys. Static NAT used for inbound traffic. Consider, like, in over the internet, some users are sitting here. So this is our internet user. So why really we required static NAT, that we are going to discuss here now, right? So I already highlighted here what is the static NAT. So in static NAT, what will happen, right? So we know that this server, so consider this server is having a private IP address. So we are going to take here in our LAN. So which IP address? Class C IP 1.0/24, right? So for this server, particular server, I'm going to assign the IP address 192.168.1.100/24. So gateway will become 1.1 only. So that gateway is configured here in this particular interface, downstream interface of the router, right? Now, so in this particular server, guys, so this is our server. So here we are going to host our website, right? So I'm planning to host a website, https colon forward slash forward slash, like I'm going to host a ninja.com. So this is my website. So whenever user try to access this website from over the internet, from the internet, right? Ninja.com. So this user can have a, like, the ninja.com website URL, like the browsing feature from here. So when he tried to write, so but it is a private IP address, guys. It is a private IP address. So if this user is tried to access this particular ninja.com, that is not going to be happen, because so here we have a private IP address. We studied long back, right? So private IP addresses are not able to route, and even this user not able to aware your private IP address. To do that, right, to once we hosted our web server here, so what we need to do, we need to perform a static NAT. So static NAT is nothing but one to one mapping. Static NAT used for one to one mapping. So in our scenario, what we are doing, one private IP address, this private IP address we are going to map with any public IP address, public IP address. So so after that mapping, right? So generally we will have a DNS in our internet, right? Consider this is our DNS over the internet. So what we used to do, right? So once we perform the NATing, like one private IP address with one public IP address here. So here we are going to do the SNAT or static NAT, right? So that public IP and the private IP details along with this like the URL and the public IP, whichever we map here, whichever we are going to be host here in this particular website, right? That we are going to be enter here registered in this DNS. This DNS is used to call as a GDNS, global DNS, right? Then what will happen, right? So this user, like the internet user, once he browse the traffic, that traffic used to go to the internet first. From the internet, that particular user used to get the public IP address we configured, which we natted here, and that traffic directly redirect to your router. So it used to come to the public IP address, then that public IP address here, whatever the public IP we map here, right, that is going to be redirect to your traffic to the respective private IP address. So this is what your static NAT, guys. This is what your static NAT. So let me note down the points. So here we are going to use with subnet 100.100.100.0/24. So this is our WAN subnet, right? This is our WAN subnet. So I can take this IP address or I can map any IP address. Okay. So to perform the lab, right? So I'm going to do the static NATing, right? In the static NAT, I'm going to take the private IP from this range 192.168.1. X. I'm mentioning here X means I can perform the NAT for this user or like the VPC 10 or VPC 11 any user that I'm going to map with one of the public IP address. The public IP would be I'm going to take like 100.100.100.10. Consider. So this is the private IP address, right? Without we perform the NAT, this private IP address will not able to reach to the internet. So once we do the static NATing, right, with this public IP address 100.100.100.10, then the private IP, then whichever the machine is having this respective IP, right, that can able to reach the internet, and the internet user can also be reached to that particular website, right? So this we are going to do the NATing for to reach our particular website, this website, right? And here we are going to enter registered here like 100.100.100.10. This IP is we are going to map with ninja.com, ninja.com, and here we are going to perform the NAT, which is nothing but static NAT, one to one mapping. Now see, you done your work, like you hosted a website. The name of the website is ninja.com, and that web server is having a private IP address which is nothing but 192.168.1.100, right? And for that IP you are going to be do a NATing, which is a static NAT. So we have three different types of NAT. So you are going to do the static NAT. In static NAT, what IP you are going to use? We are going to use 100.100.100.10, right? 100.100.10. So whenever this internet user tried to access this ninja.com website, the first request will go to the DNS, because every user, every machine will have a DNS, right? That request used to go to the DNS, and his what request it is really? It is a like query request, right? They are going to raise a query that where is the ninja.com website. So this DNS we already registered our ninja.com with this public IP, right? So this DNS used to give the IP address to this guy 100.100.100.10. So you need to go here to reach the ninja.com. So that request again will come to the ISP. ISP used to forward to the our CE router, because here we have the IP address, right? This IP we already natted here. Till here the communication will happen with the help of private IP address. Then what will happen once the request come to here in this router from internet, and that will go to the 100.100.100.10, and that IP is mapped with this private IP address. So where is that particular server? There the request used to be sent. So this is what your private the static NATing, guys. This is what your static NATing. If you have any doubts about static NATing, just let me know. So I'm here. I'm running the like from other screen as well, because to see that okay what was the comments. If you have any doubts, I'll be there to come to respond you. Okay, clear guys. So hope there is no doubt. So this is what our static NAT. So likewise, we have a dynamic NAT as well, guys. We have a dynamic NAT. Let me explain you that as well. Then we'll perform the labs, each and every lab, right? Three types of labs: static, dynamic, and NAT. So we done about our static NATing, the explanation part. Now I'm going to do the I'm going to explain you the dynamic NAT. What is dynamic NAT? In which scenarios we are going to use the dynamic NAT? So we clear about static NAT. Static NAT used to use only for a one-to-one mapping. So whenever you are going to host your web servers or websites in your data center, so at that scenario, static NAT is a very important. Static NAT also used to called as a SNAT. Static NAT also called as a SNAT. Clear? Now we are going to discuss about the dynamic NAT, guys. So what is dynamic NAT? In which scenarios we are going to use the dynamic NAT, right? So dynamic NAT is nothing but, see here in our LAN infrastructure, we have a three different user. Like consider this is also user as of now. Okay, to understand better. So one, two, three, and four. So we have a four LAN users. So dynamic NAT is nothing but a group of private IP addresses are going to map with a group of public IP addresses. Right? I have a four users, four LAN users, right? Four LAN users, and I have only two public IP addresses. So how I am going to be map here? So this four private IP, four private IPs are going to map with a two public IP address, two public IPs. See here, I clearly mentioned you the four private IP addresses are going to map with two public IP addresses. Whenever a request come, consider, so we have here four users, right? So the first request is coming to go over the internet from this user, right, to the router. So here we perform the NAT, network address translation, that to the dynamic NAT, okay, DNAT. We perform the DNAT, dynamic NAT here in this router. So here in our see, first we need to create the access list, guys. Okay, first we need to create the access list with a group of like to provide the access. So here we have a four private IP address and four private IPs and two public IP addresses, right? So once the request was initiated from this Windows machine to this particular router, so because here only we have a gateway, right? Here only we have the gateway. So the request used to come to this CE router, customer edge router. So this is our PE router, right? Provider edge router. So this router used to translate that from private IP to public IP address. So first machine come, so it taken the one IP address from here and it used to go to the internet. So the one IP is already used. Then the second user will also come to reach the internet to this particular router, right? The second request will also come to the same. So again, we have one more free IP, right? So that is also going to take and that is also going over the internet. If the third user, now where exactly the problem will start here in the dynamic net. So now the third user is again coming to reach internet, okay, to this particular router. So how many IP addresses? For four private IP addresses, a group of private IP addresses, right? So we used to map with two public IP address that is already in a use. That is already in use. So the third user, whomever came, right? The third user has to be wait for some time. So once this connection, right? Which connection? The earlier connection has to be closed. Once that connection got closed, then only this user, the third user, will get the public IP address from this pool and he can go over the internet. So this is going to be used for like in land scenarios. It is not going to be used mostly like either you will see in the production networks or the data centers wherever you join as a network engineer or the security engineers, right? So you will see mostly the static NAT because we have the servers. So whenever we are hosting a web servers in our data center, then we need to perform a static NAT to have a internet access or internet connectivity from internet user to this particular website. And the dynamic NAT, in the dynamic NAT we can use from a group of users to sorry, a group of private IP to a group of public IP address, a group of private IP to public IP address, right? So whenever the public IP was exhausted, then the whichever the connection is coming from the LAN, that user has to be wait for some time. That existing connection has to be closed. So once it closed, then it will take the public IP address. It can go over the internet. It's a scenario of like first come first serve. So we have a two IP addresses. First these two IP address like LAN users came to reach to internet, then this router has going to do the destination NAT and it is going to send over the internet, and this router the public IP addresses are exhaust. If the third user is coming, then the third user has to be wait for some time. So this is what your dynamic NAT, guys. So dynamic NAT used to be have this kind of scenario. Now we have a PAT. The third scenario is PAT. Let me wipe out this. We'll discuss that as well. Then we'll perform the lab. So PAT is also stands for port address translation. Port address translation. So in static NAT, what we are doing? So we are doing one-to-one mapping, right? We are doing a one-to-one mapping. And in dynamic NAT, a group of private IP addresses are going to map with a group of public IP address. But PAT is a very useful technology, right? Port address translation in our production network, right? So by using PAT, guys, by using PAT, you can overcome this a static NAT or the dynamic NAT kind of issues. Like static, we are just using one-to-one mapping, and here a group of private IP to a group of public IP addresses, right? Group of private to group of public IP address, but with the help of PAT. See, this is our IP address, right? The subnet, WAN subnet we are going to take. So I'm going to assign here. Consider I'm going to assign 100.100.100.1 here. And the PE side, like see, this is our CE, right? Customer edge device. This is our PE device, provider edge device. Here we are going to use 100.100.100.2. So this IP address. See, now what will happen, guys? So if you are going to use like this, right? So by using this IP address, we can translate all our LAN traffic. You have n number of subnets, we can translate all the LAN traffic over the, okay, from this IP address. So that is what your PAT. So PAT means port address translation. By using a single public IP address, we can translate this all like this subnet, okay, over with this particular public IP address, whichever configured on the CE device. So by using this IP address, all the users can able to reach the internet. All the users can able to reach internet at a single time. So here the port address translation is going to be happen. Like it is going to be add a port numbers. So we need not to bother about the like the static NAT and the dynamic NAT. Like number of users are mm, number of users, right? The number of users are going to be how many numbers of users you have, how many numbers of users you have, that much of all the private IP address. So from LAN we used to have a private IPs, right? In the WAN side we used to have a public IP addresses, public IP addresses. Guys, you're able to see me, right? So I think my screen is stop. Let me check. Guys, can anyone confirm you guys are able to see my screen? So this is my screen. No, right? Okay, let me close. I still stop sharing. Let me share once again. Entire screen. So now guys, now are you able to see my screen? Screen not visible. Okay, so now check me. Yes, you guys are able to see, right? Okay, fine. So this is what our PAT, guys. So we discuss about PAT, right? So What is NAT? NAT stands for network address translation. We have three types of static NAT, which we are going to use for one-to-one mapping. Whenever you have a web servers hosted in your data center or in your organization, at that scenario, we are going with the static NAT, right? And this is a use case. So sites like whenever you hosted a web server in our data center, at that scenario, internet users are need to be access that particular web server or website from over the internet. So at that scenario, right, so we need to do the static NAT, right? So we have the another NAT is dynamic NAT, right? DNAT. Dynamic NAT is going to be used for a group of user, right? To be mapped with a group of public IP address, right? Group of public IP addresses. And if the public IP addresses are exhaust, right, so it's finished from the group, right, then you need to be wait that the third user or the fourth user, whenever the request is coming to the CE device, right, so the requests are going to be hold here. So the earlier request, earlier we have a three requests. If this request or this connections are break, then only the other request, other user used to get the public IP address to go over the internet, right? And the first come first serve, guys. In a pat we have a first come first serve. Sorry, in a dynamic NAT we have a first come and first serve kind of scenario. So pat is a very useful in the production infrastructure. Pat is nothing but port address translation. So guys, still you guys are not able to see my screen. I just got the comment that no. Jafar, you can see now. So I see your comment. Can you please let me know now? So still you are having a issue, or you are able to see my screen now visible? Okay, thanks, Sadik. Thanks for confirmation. Right. So this is what's NAT, right? So now we will perform the labs, guys. Now we will perform the labs so that whatever the theory we discussed, right, that you are going to learn now in a practical scenario. So stay with me, right? I'm going to tell you how what we are going to do the things, right? So this is when like clear. So guys, here we are not going to do anything in the ISP router, right? Because I need to show you what really practical things, how in the practical setup, in the practical scenarios, the NAT used to be work. That I want to show you, right? So it will take some time, but you need to be bear with the time. So if you are with me, then I'm assuring you, I'm giving the clear, like the clarity on the complete whole type of NAT, how it really work in the production network. So in the WAN side, we are going to take 100.100.100.0 slash 24 subnet. So from there, so in the CE device, like our office router, we are going to use 100.100.100.1 slash 24 IP address and the CE router. And in the PE router, provider edge router, we are going to take 100.100.100.2. So to make the connectivity between here, right? So once we done this interface configuration on the ISP router and the office router, then in the downstream interfaces, mm, in the downstream interface, we are going to take like 192.168.1.0 slash 24 subnet. So from this subnet, I'm going to assign here in this Ethernet 2 slash 0, Ethernet 2 slash 0, the gateway address 192.168.1.1, right? And all the LAN machines are used to get the followed by the IP addresses from this subnet. So for the easy purpose, we are going to assign 1.10 for this Windows machine, and this for this VPC, I'm going to assign 1.20 slash 24, and for this VPC 11, I'm going to assign 1.30 slash 24. Clear? So this is what our topology. Now to to NAT, to work the NAT, so what we require once we done the basic configuration, right, from here from our office router towards our ISP router, we need to configure the default route, guys. We need to configure the default route. So we know, right, in the routing we have a three different types of routing. One is static route, right, and the dynamic routing, static routing, dynamic routing, and the default routing. Again in the dynamic routing we have a different like classifications like IGP and EGP. IGP and EGP, right? So we need to perform a default route to reach the internet from here from our office route. Once we done our basic configuration, we need to perform the default route. Then we'll go with the static NAT. So when I'm going to do the static NAT, I'm going to take the public IP from this pool only. So I'll take any of this user IP addresses, okay, any of this private IP address. I'm going to map with that for 100.100.100.10 IP address. So I'm going to map any private IP address with this particular public IP. So once we done the natting, right, then we'll see here in this office router the translations. Once we do the natting from in office router, we used to see the translation. So by verifying that, so we can clear our static NAT, right? By verifying that, we can clear our static NAT. So let me open my lab, guys. So this is what my lab. So here we have the lab connectivity as we discuss, right? Let me take the snap. Yeah, here we have, right. So as we discuss in my lab, I'm going to configure here in this interface, like the IP address. So here we are going to take 100.100.100.1/24, right, in this particular interface. And this interface we are going to configure 100.100.100.2/24. So let me do the basic configuration first, then I'll walk through you the lab. So in this particular interface we are going to configure 192.168.1.1. So I'll open this ISP router first. Okay, let me go here. Let me open the ISP routers, guys. So we know that again, let me just even we have a time, right? So whenever you like purchase a brand new router, so once the router was on site, so once you turn on the router, right, the router will get, so how many modes we have in a router or switch. So we know that the first mode is setup mode. In the second mode we have a user mode. The third mode we have a privilege mode. Fourth mode is like configurational mode, or you can say global configuration mode. Fifth mode is interface mode. The sixth mode is line mode, guys. Line mode. So every router generally any OEM, see we are discussing about the Cisco, right? So whenever you order a device, right, whenever you order a device, the device will get to you on site. So once you turn on like powered on this router, respective router, so first you will see the setup mode. So there you will have an option of yes or no, yes or no. So by using the option, it will take you walk through you from the screen. Then we will have a user mode, privilege mode, configuration mode, and interface mode, line mode. So if you want to do any configuration, you need to jump into the global configuration mode or the configuration mode. So that's what I'm seeing here. See, so I just turn on the office router, like sorry, the ISP router. I just powered on or spin up the router, like the ISP router. So I'm getting here the mode, the dialog, that the dialog box is, this is what your setup mode, guys. So here I'm going to type no. Here I'm going to type no. So once I hit no, right, so you can see my router will come to the privilege mode, user mode. See here the hashtag symbol you are seeing, right? So sorry, the greater than symbol, it is your user mode, guys. So here I'm going to type enable. So now we are in a privilege mode. So the hashtag symbol you will see here. So to configure anything, what in which mode we need to go? We need to go into the configure terminal. So I'm in a configure terminal mode. Okay. So let me check. Do you have any IP addresses? Right. So if you are in a global configuration mode, right? So if you are in a global configuration mode, to verify anything, so you need to add do before show command. Do show IPINT brief. See here, we don't have any IP addresses on the respective interfaces. So as we discussed, so what is my agenda is, so we need to reach a internet right from here. So after we do the lab, right, so my LAN user should go over the internet. To go over the internet, what I'm going to do, right? So I'm going to do here. So this particular interface, I'm going to get the IP address from this provider, guys. So this interface I'm going to make as a DHCP. So once I get the interface here, Okay, and I'll configure the IP address here as well. So this fast Ethernet 0/0, I'm going to turn up that particular interface, and I'm requesting the IP address from the internet provider itself. So let me configure that. So interface FA 0/0 fast Ethernet. FA stands for fast Ethernet. So by default interface will be down. So I'm going to make here the command no shutdown. Enter. Then I'm going to type IP space address. IP space address DHCP. Just hit enter. So even I'll mention the description as well. The description is what connecting towards internet cloud exit. Now you can see do show IP brief. I might get the IP address from the internet. So here I'm getting the 192.168.146.146. Okay. So this is the internet IP address which I got, and I need to configure. So as I mentioned you right in this slide, as I mentioned you in this slide, right? So I configured this particular interface as a DHCP, and I got the IP address here, right? So now I need to configure this particular interface, this respective IP address 100.100.100.2/24. So what is that interface? That interface is interface FA1/0. Enter IP space address. And the IP, what IP address we decided here? We decided 100.100.100.2 and /24. The subnet followed by that subnet is 255.255.255.0. So by default, every physical interface will be down. So we need to perform no shutdown command here. No shutdown. Then I'll mention the description as well. The description is connected to CE router, right? CE means customer edge hyphen RTR. Just see now, do right to save the configuration. The command is do right. So I'll check now show IP INT brief. You can see here. So we have the two different interfaces. How we decided, right? So we decided FA 0/0, which is connected towards our internet, right? So which is connected towards our internet, and that interface is, let me take you here. Let me change the pen, guys. So you'll see we have the two different interface. One interface FA 0/0. This interface FA 0/0 is connected towards our ISP, right? Internet connectivity. So we configured that particular interface as a DHCP. So that's the reason we received the IP address from the DHCP. And so we have the one more interface. That interface is connected right towards our CE router. This is our CE router, right? Customer edge router, and this is our PE router, provider edge router. So here we assign the address 100.100.100.2. So that's what we mentioned here. Clear? Now let me check the route as well. So by default, whenever you take the IP address from the DHCP, the route might become okay. Show IP route static. So I have the default route also. So I can reach the internet from here, guys. Ping space 8.8.8. Oh, sorry, 8.8.8. You can see here I'm able to reach the internet from this router, right? Ping space 8.8.8.8. So I'm able to reach the internet from here. So my internet connectivity is good. This part, sorry, from here I can able to reach ping 8.8.8.8, right? So I can reach from my ISP's router. Let me wipe out this. So I will mention. So since from this router we are able to reach 8.8.8.8. So the internet is fine. So once we done the basic configuration on this router also, like the CE router, customer edge router, in this interface we are going to configure 100.100.1/24, and here we are going to configure 192.168.1.1. Then we'll try to ping from here to the same 8.8.8 server, and we'll see whether we are able to reach or not. So but from here the communication is working fine. So let me log in into the office router, then I'll show you. So this is what the things you need to perform in the organizations as well, guys. Okay, so give a concentration and try to learn something new. Okay, right, right. So I'm in which mode? I'm in a user mode. So here I'm typing enable. Then I'll go to the configuration mode. So if you see here, do show IP/INT brief. I don't have any configuration. All the interfaces are empty. All the interfaces are empty. So as we discussed, we are going to configure fast Ethernet 1/0. The IP address is 100.100.1/24. So to configure that particular interface, I need to go inside to the interface, right? So the command is interface FA 1/0, enter. So here we decided the IP address 100.100.100.1 and followed by the subnet mask is 255.255.255.0. So by default every interface will be down, so I'm going to use the command no shutdown, and I'm going to use the description as well. This interface is connected towards the internet, right? Connected towards PE-RTR, PE router, right? Clear? We configured this WAN interface. Likewise, how we decided, right? So here, this interface, which interface? Like this Ethernet 0/0, I'm going to configure this IP address 1.1. So to configure that, the interface E2/0, enter, IP space address. And the IP address we decided here 192.168.1.1 and the subnet mask 255.255.255.0, no shutdown, okay. And the description will be like connected to LAN hyphen SW stands for switch. Now see guys, I'm going to save the configuration, write memory. The command is write memory. You will see here show IP/INT brief. By using this command, you will see that if you want the short command, you can use that also. Show IP/INT brief pipe include EX exclude unassigned. Exclude unassigned. If you use this command, right, show IP/INT brief exclude unassigned. So whichever the interfaces are not assigned by the IP address, so that interfaces are not going to show. So we have the only two interfaces, right? So here fast Ethernet FA1/0, which is connected towards our PE router, and in the downstream we have Ethernet 2/0, which is connected towards our LAN switch. And we decided that this IP addresses, the same IP addresses, we can configure. If you check here, show interface description also, you will see that. See here. So the description is, so one of the interface is going to be connected. See, this interface is going to be connected towards your PE router. The other interface, it is going to be connected to your LAN switch, right? Clear. So we have the IP address. If I try to ping from here 8.8.8.8, so it is not going to be ping. Why? Because in general in the production network also, this is what going to be happen, the same thing, right? So since from here we are able to reach the internet, but from here we are not able to reach the internet because here we have the route. So what we have here we have the basic configuration. Basic configuration means the IP address assignment. IP, here we have the IP assignment, first thing. And the second thing, here we have the route as well, right? We have the route. Check. We can see the route from the ISP's router. Let me open the ISP router. This is ISP router, right? Let me configure the host name, guys, or else you will get confused. Configure terminal. The host name is ISP-RTR. ISP-RTR. So this is my ISP router. If you check here, uh, show IP/INT brief. So we have the two interfaces and we configured both the interfaces. If you check show interface description as well, so you are going to see that. So one of the interface is going to be connected towards, right, towards your internet cloud. FA0/0, which is connected towards your internet cloud, and FA1/1, which is connected towards your CE router. Who is your CE router? So this is our CE router, right? So this is our CE router, customer edge router, and this is our PE router, provider edge router, right? So one interface is connecting towards your internet cloud and the other interface is connecting towards your cloud. So we have the IP address configuration, and now we need to verify that we really have the route. Let's see here. To verify the route or the routing table, the command is show IP route static. I'll mention here static. See here, we have the default route, right? We have the default route to reach anything, right? To reach anything 0.0.0, it has to go 192.168.146.2. So where is that 2? So here I mentioned. So in this cloud, we have this IP address. This is what our gateway from here. So it has to reach to here. Clear? Now, so if when I try to ping from this particular router to 8.8, we don't reach because we don't have a route. So we have only the basic configuration, which means the IP address assignment on these respective interfaces, on this respective interfaces, but we don't have a route in this particular router. So once I configure the route, then you will see we can able to reach internet. So this is our office router. Let me configure here. IP 0.0.0 space 0.0.0. To which route, which IP address we need to be point the route. So you guys, I'm trying to give you like the valid things what exactly in the production network also we have. So here we assign 100.100.1/24, right? In this interface we assign 100.100.100.2/24. So what we need to do now, so we need to configure a default route, right? We need to configure a default route to reach the internet from this CE router. This is our CE router, customer edge router. So what is our next hop? The next hop is will become this, right? So we need to go from here to here, right? So this will become our next hop IP address, guys. This IP will become the next hop IP address. What is the syntax to configure the route? So I'm saying here in the office router, I'm in a office router, I'm saying that IP route, show the route to 0.0.0 followed by this IP address and the subnet mask also 0, and my next hop will become 100.100.100.2 because I don't know anything. Like see, if my user used to come right to reach the internet or to reach 8.8.8.8 from here to this particular router, my router used this route because this is the least preferred route, a static default route towards the internet. This is the least preferred route, and my router used to check the routing table. This office router used to check the routing table, and it used this route. By using this route, because here we are matching the subnet, right? This 8.8.8, we have the routing in the routing table. This is our default route. So it used to forward the traffic from this router to ISP. Let ISP will take care, right? Let ISP will take care. So generally we will have a 8.8.8 google.com or Google server in over the internet. So my traffic will go to the ISP and ISP will send to this, and then again it will back to here, forth and back, right? So now I'm going to configure this particular route. So IP route, right? 0.0.0 and subnet will also be 0. My next hop will become this IP address, right? 100.100.100.2. See here. So that's what I'm going to be use 100.100.100.2. Just hit enter. To save the configuration, if you are in a global configuration mode, then the command is do write, right? Do write. Let me save the configuration, and if I try to ping from here, ping space 8.8.8.8.8, see the magic. What we learn, we are not only learning the NAT, we are learning the basic setup as well, right? So how we need to be set up. So to reach internet, we required the IP address configuration, right? The first thing, let me take other pen, else you will get confused. So what things we required? We required first the IP assignment, IP address assignment on the interfaces. Then in the second thing, what we required, we definitely required a route to reach the destination. We required a route. What route we are going to use here? We are using default route. Even you in your CCNA also you studied, right? To reach unknown destination, we used to configure the default route in our router. So this is what our router here we configured the default route towards our ISP. So in our example, who is our ISP? This is what our ISP router. So we need to reach to this guy to reach anywhere. So we have a hell number of services over the internet. So to reach those services, what we need to do, we need to reach to our ISP guy used to be maintain the routing table of internet, because so here they are going to run the BGP kind of stuff, and they are going to maintain the global routing table. What we are maintaining just the normal routing table, whatever the routes we have in our infrastructure, right? So we done that, and when we are trying to ping from here, ping.8.8.8.8, so we are able to reach from this particular router. So our connectivity is fine, right? So if you try to ping from these machines, then you will not able to reach. That we can verify from here itself. Okay, I'm in the office router, so that I try to ping here. by using source like source address 192.168.1.1. If you see that, so I'm not able to ping, guys. I'm not able to ping. So why I'm not able to ping? I told you, right? So whenever, even though if you try to open this user, let me open this user, like the IP address is 1.20. Let me open this user so that you will get to know what is IP. Show IP. Okay, here we have the IP address is 1.20. So if I try to ping my default gateway 192.168.1.1, I can able to reach, which means the connectivity is through. The connectivity is through here, from here where I can able to reach from this machine to my gateway, which means the connectivity is there till there. If I try to ping from here, ping space 8.8.8.8, I'll not be able to reach. Let's see why. The same PC. Now I'm pinging from here 8.8.8.8. See what output we are getting? We are getting ICMP request 1, 2, 3 is timeout, right? So we are getting the timeout, which means the connectivity is not there. Even though we have the physical IP addresses are configured here, right? Here 100.1, here 100.2 slash 24 slash 24. So since from here we are able to reach 8.8.8, right? Ping 8.8.8.8. Even from this router I'm able to reach 8.8.8.8. But by using this particular source, when I try to reach, right, I'm unable to reach. Even though from here as well, right, from this PC I'm not able to reach. So to do that, to reach that over the internet, we need to perform NAT. I told you, right? So when we are going to when we are discussing the points, right, when we are discussing the points, what I inform you, the private IP addresses are not able to route over the internet. Private IP address. So this is what your private IP address. What is 192.168.1.20 is your private IP address that will not able to route over the internet. So this WAN side that is not going to route this side. So what you need to do, you need to perform the NATing. So in our example, we have a three different types of NAT, right? Static NAT, dynamic NAT, and PAT. So we'll do the NATing now. We'll do the NAT, a static NAT, then understand how the NAT is going to be work. So I'm going to use this 1.20 PC, right? So the private IP is, I'm going to use the private IP is 1.20, and the word public IP I'm going to use here, the public IP from this same subnet. Here we have, right, 100.100.100.0 slash 24 subnet. From this subnet I'm going to be used. Okay, so here I'm going to use the IP is 100.100.100.10. So this IP address I'm going to translate with this below private IP address. Below private IP address. Let's see how the magic used to be work. So 1.20 is the private IP address, right? So whenever this user 1.20 is trying to ping over the internet, so that IP is going to be translated with this IP address. And if the reply is come, reply is going to be translated from public to private. So that is what your static NAT, right? So in the static NAT, we are going to do the NATing or mapping 1 to 1. So in the static NATing, we are going to do the mapping 1 to 1. So here we have a one private IP address. That private IP address I'm going to map with the one public IP address. To do that, what I need to do, guys? So to do that, the static NATing, what we need to do? So to do that, the static NAT is like, so first we need to specify. We need to specify which IP address we are going to take, right? So which IP address we are going to take and how we are going to be configured, right? So the syntax is very easy. Syntax to configure the syntax is very easy. So in the office router, I'm going to specify that. So once I jump into the global configuration, then the command is IP. So I'm going to use NAT, from where inside IPNAT inside, right? IPNAT inside. Who is the source? Which type of NAT I'm going to use? I'm going to use static from 1.20. So this 1.20 I'm going to map with 100.10. So this is what I'm going to perform now. See, I'm going to use IPNAT to whom inside users who will become my source, and the static NAT 1.20 is my source, and that IP I'm going to map with the 100.10. So 100.100.100.10, right? So once you've done this, the statement in the global configuration of this particular router, right? In this router, in this router. Then I need to specify that, right, the direction as well. So generally traffic used to come from this direction, right? So this will become in, and it used to leave from this direction, so it will become out. So in this particular interface I'm going to specify that IP NAT inside, IP NAT inside, and in this interface I'm going to specify that IP NAT outside. That's what your NAT things. That's what your NAT configuration things I'm going to do. So first I will be in a office router. So once I log in into this office router, there I'm going to specify that this particular command to specify the statement IP NAT, right? IP NAT inside. I'm going to do the NAT for inside, and the source will be my static NAT. And this private IP address 1.20, I'm going to map with this 100.100.100.10 IP address. So once I specify this command in the global configuration, then I'm going to identify that which interface will become in, which interface will become out. So generally my 1.20 user is sitting in my LAN. When he try to initiate the traffic, that traffic used to hit on this particular interface. So this interface will become inside, and if it leaves this particular CE router, customer edge router, so this interface will become out. So that's what I'm going to configure, guys. So let me open my office router. So this is my office router. So whatever I decide here, right, the same thing I'm going to do. See here. So as of now, even though when we try as a source, it's not going right. Even though when we are trying to ping from source as well, also it will not going. So I'll do one more thing. So I'll use this time source not 1.1. I'm going to use 1.20. Let's see, is there any changes? So invalid source, so that 1.20 is not there here, right? So let me configure the NAT. Now global configuration. So what we decided, we are going to configure IP NAT and the inside, right, inside, and IP NAT inside source. Okay, what type of NAT we are going to use? You can use, guys, one more thing. Networking is like the very easy thing. So if you don't know the commands, right, you can use this one, like IP space. Once you type NAT, use question mark, so you'll get here inside or outside or pool services translation create. So I'm going to use inside, so my users are sitting inside. Now here, the source NAT, you are doing source NAT or the destination NAT. I'm going to do the source NAT. Okay. So IP NAT source. If you use question mark once again, here it is giving a list or a route map or static. So you can use a static for the static NAT. List means when you are going to do the dynamic NAT, right? So are the pad there, you need to configure the access list, guys. So that access list, if you are going to use by access list, then you need to select that this list. So in our example we are going to do the static NAT, right? So in the static NAT, IP NAT inside source static. Okay, just type st and hit tab, so you will get the helping command also, static. Then what you will see here, see here, inside local. So what is the inside local? So in our example, inside local is what? Let me take my pen. So in our example, inside local is what? So inside local is this 1.20, right? So that's what we mention here, inside. This is the inside IP address. So LAN means what? You are inside, right? So 1.20, I'm going to mention here 1.20 office router. So here I'm going to mention inside IP address is what? 1.20, right? So 192.168.1.20. Then if I use question mark, then again it is going inside global IP address. So from which IP address you are trying to map? So the global IP address in this router, I'm going to trying to map this 1.20 IP address with this particular guy 100.100.100.10. So that's what I need to specify there. So inside private IP address is 1.20, and the inside global IP address is my public IP address is 100.100.100.10. So that IP I need to specify here. See here. See, right? So here I'm going to type 100.100.100.10. Just hit enter. Right, so this is what the configuration statement for the static NAT which we need to be used. So whatever we discuss here, the same thing like I mentioned the command. So let me come out. Right now I'll save the configuration. So write memory. So as we discuss, guys, right, so as we discuss what we discuss here, so here, so we need to specify the interfaces also, right? So we need to specify the inside interface or the outside interface. So Ethernet 0/2 is my inside interface. So again, I'm in a configuration mode. Inside E2/0, enter IP NAT inside. So before you configure, just check whether we have a configuration anything intact in this particular interface. To check that, the command is show run interface E2/0. If you type here, right, so we don't have any configuration like NAT related configuration. We have just the description. This Ethernet 2/0, which is connected towards your LAN interface, and the IP address is 192.168.1.1. So here in this interface, I'm going to type IP NAT inside. You will see in the question mark, you will see only inside and outside. So here I'm going to type IP NAT inside. Just hit enter, exit. So if you check now, show a run interface E2/0, right? E2/0. Now you will see the inside IP NAT inside. So earlier it was not there. When we check, it is not there. So just now we configure. Likewise, we need to configure FA 1/0, which is connected towards your internet. So the direction is out, right? So this is what the direction. So that so the direction is out. So that direction we need to configure in this particular interface. Let me open that again. VPC, like the office router. So this is our office router, right? So interface F interface FA 1/0, enter IP NAT outside. That's it, guys. Exit, again exit. Right, ma'am. Earlier, when we try to ping, right, when we try to ping, we don't have a connectivity, right? See, even now, let me configure host name as well, guys, or else you will confuse. Host name office -rtr. Now see, guys, so earlier we used to ping space 8.8.8. It was reachable, right? Now also it is reachable. If we use source as a 192.168.1.1, it was not reachable. Now also it is not reachable. Now also it is not reachable, right? So when we try to ping from this VPC, right, from which machine, from this machine, like 1.20's IP address, earlier the internet is not reachable. Now we will see some changes. So this is a VPC 10, right? Earlier when we try to ping space 8.8.8.8, it was not reachable. Now see here, up arrow, just hit enter. See, now we are able to reach the internet. Now we are able to reach the internet. This is what the difference. I told you clearly. See, NAT, without NAT, your user will not able to reach over the internet. So consider this is our, like, what is this? This is our server. So I can change the like the image also. So that is not going to any impact. Okay. So earlier we are not able to ping 8.8.8 before we do the NAT, static NAT. Once we do the NAT, we are able to ping the 8.8.8. So now in this particular router, right? So now in this router, you can see in this router, you can see the translations, guys. This is our office router, right? Let me open my office router, right? If I check here, show IP NAT translation. See how many translations we have. How many translations we have? See, this is what our private IP address, right? This is our private IP address 1.20. That's what we discuss here. 1.20 is our private IP address. This is what our private IP address 1.20, which we map with 100.100.100.10, right? So the same thing you can see here, guys. The same thing you can see here. See, 1.20 we map with this IP address. So whenever this 1.20 user is trying to reach internet, that IP is used to be translate with this 100.100.100.10, right? See here, this is what you inside local. Inside local means inside. This is your inside. 1.20 is your inside. The local IP address is this. And the inside global IP address is nothing but your public IP address, which we map, right? So 100.100.100.10, right? So outside IP. So to which IP address it was reached? It is trying to reach 8.8.8.8, right? The same thing. Now, so we achieve that the static routing lab. See here, we can able to reach the internet. If I do the lab, you see this is our Linux PC, right? If you want to check the this one, right, the internet browsing also, that is also possible. That I will show you in the pad, right? Now we saw the translation as well. So translation also working fine. Everything is working fine. We don't have any issue on the static route lab. Do you have any doubts, guys? Just let me know. I'm watching your chats. Okay. Do you have any doubts on the static route? Just let me know so that I can explain you in a better manner. I try to. Any doubts, guys? Do respond over the chat. Yes, I'm waiting for your response. I'm waiting for your response. If you have any doubts, just let me know on the static route. So I can see there are 14 guys are watching, right? But I didn't get any response from you guys. Syed Jafar, no doubts. Sneha, thanks for confirmation. Syed Jafar, Smiley, sisters are Sneha already updated, right? Maksud, Sai Kumar, Ayman. You have like around 14 guys, right? Lukman. Yes, guys. So I can see the comments. No doubts. Muzammil, thanks. So got the comment from the Muzammil also, no doubts. If other guys are watching, okay, we did NAT for inside outside user can ping inside user. So Sadiq, we did NAT from inside to outside. Users can ping inside user. Yeah, user inside user can able to ping the. Okay, so I got your point. Okay, inside user can able to ping Sadiq. Let's see here. Let me show you. So this is what the NAT, right? Let me wipe out once again. See, this is the 1.20 PC. For this 1.20 PC, we tried to NAT, right? So private IP 192.168.1.20. This is our private IP address. We tried to NAT with this IP with 100.100.100.10 public IP address, right? Whenever this 1.20 user try to reach internet, right, so this IP will translate with this 1.100 and it used to reach the internet and the vice versa traffic used to come, right? Now if you try from this user side, these users will not able to reach internet because we are not doing any NAT. What is static NAT first, right? The static NAT is one to one mapping, right? Static NAT is one to one mapping, one private IP address we map with the one public IP address. If you try from this VPC 11, this user will not able to reach internet, right? Let me open that VPC 11, right? VPC 11. Let me open this PC. If I try to ping from this VPC 11, let me confirm you the IP address, show IP. So here we have the 1.30 IP address, right? 1.30 IP address. If you try to ping space 192.168.1.1, it will reach to your gateway 1.1, right? You can able to reach the gateway. If you try to ping 8.8.8.8, you're not able to reach because we haven't performed any kind of natting, right? So we perform only static nat. We perform only static nat. Okay, whichever the IP we map, right, only that IP can able to reach over the internet. Now see, so we try to map with this IP, right? This 1.20 we map with this. So that's the reason from this machine we are able to ping 8.8.8.8, right? Now in the same example, forget for some time, this is your 1.20, this is not 1.20, this is your server. Okay, consider this is your server and this server IP address is 192.168.1.20 and this is our web server. Actually, generally this is our web server. In this web server we the website we build, right, that is our https colon forward slash ninja.com. Okay, this is our website which we build for like to online students to be registered. So this 1.20 IP address we map with 100.100.100. So I told you, right, static NAT is one to one mapping. So static NAT used to do for whenever you have a web server in our infrastructure in our data center. At that scenario, that is a use case scenario that we are going to be used, right? So this is our web server and the IP address is 1.20. That same IP address we map with 100.100.100.10. Now anyone can from the outside user who is sitting outside user, right? This is our outside user, guys. Outside a user, this guy can open a browser, right? Once he open a browser, he can try to, when he tried to access this https forward slash colon uh, https colon forward slash ninja.com, right? So that request will come to internet first, right? That request will come to internet, and like in internet we have a DNS, right? Global DNS. I told you, right? We have a global DNS. So this is going to give the IP address of 100.100.100.100. The same request will come to your router because we configured here 100.100.100.10 is here. So that IP, right? So once the request is landed on this IP, that is going to be translated to this private IP address. So the request used to be come from here to here. So that is how used to be work in the websites. If you have a web servers, guys, if you have a web server, and this is how it used to be work. Now hope Sadik, your doubt is clear. So for the practical scenario, right, I just perform the NAT, static NAT, for this particular user. You can perform for the web server also. You can take any server, or else you can take the router and convert that router as a server, and you can try to perform. That is going to be work. Clear? So this is what your static NAT, guys. This is what your static NAT. So likewise, the dynamic NAT, right? To do the dynamic NATing,